Good evening, everyone. I am Sagar. I'm pursuing BTech from Mechanical Engineering at IIT Delhi. So my topic is assessment of marine sediment bearing pressure using acoustic approach in shallow water regions. So first is what is sediment bearing pressure? Sediment bearing pressure is the maximum contact stress the seabed can carry without catastrophic shear failure or unacceptable deformation. For the calculation of sediment bearing pressure, we have the Reimagine-Meyerhoff's basic equation. Here is a simplified 2D version form of the equation. We need some properties of the sediment that those are cohesion factor, effective overturning pressure at foundation level, and internal pressure angle for the calculation of bearing capacity, and other physical factors of our foundation team. Next is why our sediment bearing pressure is important. So we all know there are a lot of bridge collapses occur in our country. So apart from the mechanical failure, mechanical and or material failure, main reason for the collapse is the improper or incomplete calculation of the sediment bearing pressure. Moreover, the precise calculation of sediment bearing pressure will also avoid the catastrophic failure of offshore infrastructures, will help in the submarine pipeline and sea anchors, and is the basic requirement for amphibious and logistic operations. Next, where my project will be applicable. So basically sediment bearing pressure is applicable in all these categories, but my project will scale up all these things. So firstly, the foundation stability. Anything we are going to make on the seabed, we need some value of the sediment bearing pressure, that how much load can it bear. For the amphibious operations of military, we need there is a heavy machinery that needs to be supported by the ground. For that, we need sediment bearing pressure. Also for the subsea mining and robotics, those crawl on the seabed. So that is the basic requirement. Moreover, by the acoustic mapping of all the Indian Ocean region, we will be able to come up with a better defense strategies for the country in case of by knowing the all the sediment bearing pressure at all the Indian Ocean regions. Next, what is the difficulty in the tropical seabeds and temperate seabeds? So in our case, Indian Ocean region, we have tropical seabeds, where the lot of decomposition occurs in many ways. First is common rainfall or physical ones. Other one that a lot of sediment comes from the rivers, coming from the mountains, and other human factors as well. These factors lead to highly variable sediment bearing pressure and very low pressure as well, which is quite opposite of the temperate regions or non-tropical seabeds, where the sediment bearing pressure is comparatively higher and more predictable. Next, what are the calculation steps? So basically, there are three methodologies that are used in the calculation of sediment bearing pressure. First is the physical method, where they take the sediment from the seabed and do mechanical test on them and calculate the sediment bearing pressure. Another approach is they try to model the FEM, model the sediment in the software, and then use nonlinear finite element method to calculate it. And another approach is using acoustic data from the seabed and then make their own biostole poroelastic model, which then will be used to calculate the sediment bearing pressure. So what are the current gaps? Basically, for the FEM case, we can say that it is very difficult to model all the real case scenarios, real case complex scenarios, and also it will be very computationally expensive to get precise value of this. Next, for the acoustic one, biostole model, there is no proper methodology provided for the optimizing. And for the shallow tropical regions as well, there is no proper approach research on. Also, there is no current real-time acoustic data integrated in the seabeds. So what my approach will be is work on the acoustic method, where we'll define the sediment properties from the acoustic data, and then try to find some empirical or any relation, or if possible, try to use machine learning algorithms to optimize the biostole model, and then integrate the real-time bearing capacity. So how I justify is that this project will be non-destructive to the sediments, will be low cost, and will be very highly scalable over the tropical seas. So that's it. Thank you.